Okay, this is section 3.3, and we're looking at the first derivative test. Okay, so again, we're looking for relative. Okay, this is all about relative extrema. Okay, so it's relative extrema. And we just use this idea of increasing and decreasing. Now they call it, they have a theorem number here, so it's theorem 3.6. And they say, let C be a critical number. Now, so that means that either the first derivative of the function is 0 or it's undefined. So it's critical number of a function f. And now notice that they say that is continuous. Okay, so now, so you're not going to have any critical numbers due to discontinuities in using this theorem, but you may have points or something like that due to things like absolute value and all that. So that is continuous on an open interval, and they call it I, an open interval I containing C. Okay, so C is sort of in the middle somewhere, in there, containing C. Okay, then they say if f is differentiable, okay, we can take its derivative if it's differentiable on I, on that interval, except maybe at C. Again, because a critical number could be where the derivative is undefined. So, except maybe at C, then f of C is classified as and they say just as follows. Okay, so what could happen? Well, they say one possibility is that f prime of x goes or changes from negative to positive. At C. Okay, so it goes from negative to positive. So here is f of C, and the derivative was negative. Now it's positive, and so then f has a relative minimum or min at, and they give the point C, f of C. Okay, so that's one possibility. Another possibility is f of x goes from positive to negative. At C, and well, if it went from positive, so it was increasing, and then it is decreasing after C. And, well, in that case, then F has a relative max or maximum at C, F of C. And then finally, it could be that oh, sorry about that. I just started thinking, did I say F or F prime? I did it right here. I said F prime, the derivative, right? And then here, F prime, the derivative goes from positive and negative. And then finally, F prime of X, stays positive or stays negative on both sides of C. Okay, so that could happen. In which case, well, if it stays positive on both sides, so it's increasing, hits at C, and then continues to increase, or negative, it's decreasing, hits C, F of C, and continues to decrease. Okay, one of those two things happen. Then C, F of C is neither a relative min or max. Okay, it's not a relative extrema. And so that is what they call the first derivative test. You find your critical numbers, and then you look on the right and left close to it before another critical. You don't want to be on the other side of yet a different critical number. You want to be near your critical number. But you just look, what's the derivative doing on either side? And if it's negative and then positive, then that's a minimum, positive then negative, then a maximum. And if it doesn't change, then it's neither. So there we go. That's the first derivative test.